Good morning, good afternoon, good evening. This is Professor Sistrunk, and I'm reaching out to my Cisco students. Switch networks. Yes, let's talk about switch networks. Okay, but before we start with the switch networks, I just want to point this out to everyone that this will be a very short chapter. And the reason it'll be a short chapter is because you know everything you need to know about switch networks. You may not think so, but you really do. Now, switch networks in and of itself is really good to know basically because these are the workhorses of the network. Switches are the workhorses. They take care of the network, so they are very important. But like I said, before we start, know that we will not have class tonight because you pretty much already know about switch networks. I'm just going to highlight a few things. And also, I have to get a lot of grading done, and I want to spend that time grading while you guys spend that time catching up whatever you need to catch up. At this point in time, make sure you have your work in so you can catch up. But anyway, let's move forward. Switch networks. It's going to be a really short chapter. You're going to blink your eye and it's going to be over with. So we're talking about two different layers of switch networks. And when I'm talking about that, what I mean is we have the design layer and we have the environment, switch environment. Now, you have to know a little bit about designing, but don't get bent over because you're saying, oh man, do I have to know all this about designing? No. Remember, Cisco is a progressive grow. You're going to grow into a lot of different things as you move through the different levels. But just know that when it comes to switch network and the design part, you just pretty much want to pick up on a few things in here. Rest of it you already know. Then when we talk about the environment, we just talk about how it's set up. So let's move forward. Okay, the design. Let's go into it. Yeah, you know that we have real complex networks now. I mean, these are massive networks. They have a lot of things going on. It has to be secure, it has to be reliable, it has to be available. If I leave my office, I should be able to tune in, connect to my network anywhere I am, or rather anywhere you can get an internet connection, you should be able to connect to your network. Also, you know, we are global. I mean, if I get on a plane right now and fly to China, I should still be able to connect to my network. Now, I know you're going to say, well, Professor, don't China got the iron wall where you can't get out on the network? I'm a VPN up out of that, baby. You better believe that. Okay, let's move forward. Okay, so now, we talked about converged networks or converging our networks. That means everything is now on one different platform. So you got your internet, you got your telephone, you got your email, all that on one platform. I don't have to talk about this too much because you know this. We went over there. We done beat this horse to death right here. Let's move forward. Okay, now borderless networks. That means, like I just said earlier, I should be anywhere on the planet, or I could be anywhere on the planet and be able to time into my network. I want to make sure that I can connect and do my job anywhere that I am. And you know, and I know that we can do that. If you see me looking down, I'm pretty much looking at my notes. So if my eyes go down, I'm looking at the notes to make sure I'm doing the right thing. Even though you reading what's on the screen, I want to make sure that I point out particulars in this particular case. And when it comes to borderless networks, I'm just saying that just put this in your head. I can be anywhere and do my work and connect to my network. And as you can see with this pandemic that happened, everyone is working from home. So networks have to get really robust and tuned up to be able to handle that load. And that's when the switch is really doing the work. If you take a look at these switches here, you can see they stacked switches. You can see they switches that can be turned into routers. You know what that switch is. Let me see it. And then you can see these routers here. So routers are just the connection from one network to the next network, but the switches handle the bulk of the work. Okay, moving forward. Now, taking a look at this hierarchy network, you see that you have industry switches with firewalls connected up here. When you see these red bricks, that means that router, I said switches, but that router has a firewall connected to it. And everybody know a router is nothing, any router can be turned into a firewall. You already know that. It don't have to actually be bought and paid as a firewall. You can turn it into a firewall with your configuration. Then you see these core layer switches. These are these powerful switches that I talked about earlier that has a lot of power in them, and they really handling the load of the network. And then you have your 2960s, etc. right here that you deal with it on a consistent basis in this class. Yes, I said consistent basis because you should know how to configure one of these by now. Yes, you should. Basic configuration. Okay, moving forward. Now, I'm going to go back for a second. You see the language here, the hierarchy, the flexibility. These are key things. Access, distribution, and core. That's what they mean right here. This is your access level. This is the level we are really working on in this class. But you got a distribution level to carry that load from one location to the next. And then you got your core level. Just know that this area here that I'm making a circle around, see, I'm jumping all around. Let me jump back. This level here that I'm making a circle around is a level that you're not working on now. They just explaining it. This is theory, and we're explaining it to you right now. But the level that you are concerned with is this level right here, which is called the access layer. Okay, moving on. Okay, so back to the access, distribution, and core levels. Same thing. These switches here, this is why this is the level you're working on, can be on any particular floor. Now, we're not going to have that much of configuration and stuff like that in here because we don't actually have to do a configuration for this particular chapter because you basically, the stuff we covered in the previous chapters pretty much gave us the configuration we need to go forward. But as we go forward, we're going to work more and more only on the actual configurations for switches. Make sure you know that. And this showing that it can be on any floor. Now, it doesn't actually have to be on different floors. It can be in one big room, depending on how big the organization is. Then it falls over to the distribution layer, which takes you to the actual router. Now, you don't see the core layer because remember, core layer, distribution layer, it is basically how the network administration set their networks up. So you may have a core layer, you may have a distribution layer, or you may have a distribution layer or a core layer, or you may have both of them. It depends on how big your country, really? Did I say country? It depends on how big your company is. Man, why was that hard to get out? Work with me, people. I don't know what's going on. Anyway, role of switch networks. Quality of service, additional security, support for wireless network, and support for new technologies. So the new switch networks that's out here, and when I say new, you got to take that with a grain of salt. These are the most important things that are in there. So if I ask you anything, I say, so what is the role of switch networks? You're going to tell me core, additional security. Security is a must. You cannot play games with that, etc., etc., etc. And just look at this. Like I said, this level, these two levels here, you don't have to worry about. You just want to focus on this access layer. Okay, now these are different platforms that we have used in the past, and most of them are still here. I don't think anybody doing a stackable configuration anymore. I haven't really seen that in a while, but you may have organizations that still do that. That's just the daisy chain effect, where they take one connection and connect it to another one. They just making sure all of the switches are communicating with each other, you know. So that's called the daisy chain effect. This here is what we call a fixed configuration, meaning You just keep buying a certain amount of switches to as your company begins to build. So you may have started with this one, then you added another one, then added another one, then added another one, and so on and so forth. And you could daisy chain these like this here. This could be this here. But this is when you know you playing in the big boy arena, when you got modular configuration, meaning you can pull these out and add in blades because you can just pull them out and swap them out. This is built for huge companies and it costs a lot of money, a lot of money. So you're going to see cost, port density, power, reliabilities, port speed, frame buffering, scalability, and here's the ultimate scalability because you continue to go up, up, up in the way. Okay, so now that covered basically the design of switches. As you can see, it wasn't that much. It didn't take, you pretty much already knew it. Didn't take a lot from you, or in other cases, you know, you had to learn a lot. But that's pretty much that. Now we're going to talk about the environment of switches. So, you know, a lot of people try to get down switching as a general concept in networking and telecommunications. Yeah, we tell you the LAN. Now, you know me, when I say LAN, I'm talking about a switch. So when you see me say LAN, you know I'm talking about the switch. And when I'm talking about the switch, I'm talking about in your house, your company, your network, LAN switch, your network. When I say something about a router, I'm talking about the WAN, your router, and then I'm talking about in the outside world. So you got to be able to equate or put together those three things when you're talking about it. And they talk about a LAN switch maintains a table. We already talked about it. You heard about the routing table. Now you got the switch table. So you know every switch has a table inside of it so it can recognize the different devices that's connected to it and so forth. You already know that it's a layer 2 device. If I say what layer is the switch on, I asked some students this a couple of days ago. I said, hey, what layer is the switch on? Layer 1. I said, oh my God, no, you didn't say that. Don't do that. In other words, you know, to make sure that you know which layer is this. The media is layer 1. The switch is layer 2. And the router is layer 3. Now, understand this. In being a network engineer, those the layers you will work with. Those the layers you will manage. So don't try to think of the other layers. You need to know them, but you shouldn't go above layer 3 because you're the network person. And that's why you have that title, okay? Now, in reality, we work on all the layers, but your primary function is those 3 layers. Okay, moving forward, you will have a video in here. Go through the video and take a look at it. I don't know why I kept this slide in here. Normally I get rid of them. Also, we talked about switch forwarding and the methods of moving data from one place. You have store and forward, and you also have cut through. Now, I'm going to be honest with you. You know how I'm about cut through. Cut through is the fastest and best way to go. But I'm going to be honest with you. You really don't get to decide this unless you, when you purchasing a device, you say you want cut through. But most people, when they buy switches, it will be stored and forward. And I don't have to explain that to you. You know what stored and forward is, and you know what cut through is. It's just a matter of how the data moves from one location to the next location. I just explained it to you. Why? Anyway, so just know, make sure you understand those two concepts. But the most important thing is don't bog yourself down with it, because the network engineer or the senior network engineer will be purchasing the devices, and he will tell them how he wants it. Even if he bought a cut through switch, meaning the application on there is set up for cut through, that comes from a manufacturer. And if everything on his network is stored and forward, that cut through switch will default to stored and forward. So you don't have to worry about that. Just know the term if you hear it. Okay, and it's talking about how stored and forward switching work. Now, I had a student reach out to me and say, hey, I'm not understanding all this. Just make sure you just know the different titles. You got a frame header, and in the frame header, what's in the frame header? You got the network header, the transport header, and the data. It's going to be times when I'm going to point out particulars that you need to understand about these particular headers. But in this case, you just want to know that these are the things reside in it. Don't beat yourself up with it. Make sure you just know it and move forward, okay? But this is how you store and forward packets that are in here, okay? Or excuse me, frames. Packets, we dealing with the router, but with the switch, we talking about frames. You see how different it is? It's the same thing, but they give it a different name depending on what the device it is, okay? And the same with cut through. Just make sure you understand these particular headers. Frame header, network header, transport header, data, and what they do, okay? That's all you got to do. You don't bog yourself down with it because it's already built in and it just should be something you should know about. You can't change it. You can't manipulate it, but you will know if someone else did try to manipulate it and change it. Because if a packet leaves one place or a frame leaves one place and it gets to another place and it's changed, you'll immediately know. So, yeah, you got people out there hacking frames and packets. They want to know what you know. They want to get in your business. Collision domains, we can say a lot about collision domains, but we talked about it especially in the first book. The first book was all about collision domains, making sure that you do not have collisions on your network. You want to minimize it. And guess what? When we brought forth switches, that cleared up everything. That cleared up all collisions. Now, do collisions happen on switches? Yes, but they so minimized that you really cannot tell what's going on. Okay, so you could have a collision, but in theory, no. But it talks about hubs and all that, and we're not going to go back over there. We're not going to beat that horse to death because we know pretty much all about that. Do half duplex. We're not trying to have half duplex. We're trying to have full duplex. That's why we bought switches. Moving forward. Okay, broadcast domains. Just remember that on any given network, they have what we call a broadcast domain. And the important things about it, one switch or multiple interconnection switch from a single broadcast form a single broadcast. When a switch receives a broadcast frame, it forwards the frame out to each of its ports. But remember, it has to be on that network. It don't just send it all around the world, just that network. So you pretty much, like I said, we went through broadcast domains. And if you know, most of you went through the first book, so you know all about broadcast domains moving forward. And if you don't, just go back and read a little bit on it. Just know the difference between broadcast domains and the rest of them. Don't really beat yourself up over it. Okay. So now, once again, we're taking a look at the following characteristics of switch help. You can see right here. I mean, this is basically everything that you want in a switch. Established full duplex, high port density, large frame buffers, speed, etc., etc., etc. We covered all this before, but this is what you're looking for. If you want to take any slide out of here and keep it, this will be the one. This is how my switches should be working. There it is. Okay, and that was it. I told you this was going to be a really, really short chapter. Now, let me piggyback up on a few things that I said earlier. One, yes, we will not have class tonight. Class is at 6. We will not have it. You'll be receiving this, but in your email, it will stay the same. I know a lot of you are busy working, so get your work in. This is going to be that time, that grace period week, when you get a chance to get all your work in before next week. And my thing will be to catch up on all of the work that need to be graded. So that's what I'm going to be pounding out. And you know me, I'm meticulous in going through every assignment. A lot of you emailing me back, well, Professor, I didn't know it was supposed to be this. But that's how I am. I want to make sure that I look at your work and see what you're doing. With that being said, this is Professor Sistrunk. I enjoyed this time with you. And if you need to contact me about anything, you know what you do. Phone first, text first, phone second, and the last thing is email. You know how I do it. Sayonara.